So in this video, we have to prove that in triangle ABC, R plus R1 plus R2 minus R3 is equal to 4R cos C. Here, we know that small r is equal to 4R sin A by 2 sin B by 2 sin C by 2 sin C by 2. So similarly small r1 is equal to 4R sin A by 2 cos B by 2 cos C by 2. So small r2 is equal to, we have 4R cos A by 2 sin B by 2 cos C by 2. Right? Small r3 is equal to 4R cos A by 2 cos B by 2 sin C by 2. See, we have the formula like this. So now here, taking that first R plus R1 consider R plus R1. So which is equal to, we have small r is equal to 4R sin A by 2 sin B by 2 sin C by 2 and plus R1. See, R1 we have 4R sin A by 2 cos B by 2 cos C by 2. See, we have like this, right? So in these two terms we have 4R and sin A by 2 is common clearly. You take 4R sin A by 2 common, then we get here sin B by 2 into sin C by 2 plus here after taking the 4R sin A by 2 common, so this is cos B by 2 into cos C by 2. See, observe here, so this is 4R sin A by 2 and here sin B by 2 sin C by 2 and cos B by 2 cos C by 2. For our convenience, what I am writing is, first rewriting this is like cos B by 2 plus into cos C by 2, first this term writing, plus and next second term writing, that is sin B by 2 into sin C by 2. See, observe here, this is in the form of, within the bracket, which is in the form of like cos A cos B plus sin A sin B. See, we have cos A cos B, cos A into cos B plus sin A into sin B, so which is equal to cos of A minus B. See, cos A cos B plus sin A sin B, which is in the form of, so cos of A minus B. What is here A? A is B by 2. What is B here? C by 2. So it becomes what? 4R sin of A by 2 into, which can be written as, so cos of A is what? B by 2. A is B by 2 and B is what? C by 2. So minus C by 2. See, we get here Therefore R plus R1 is equal to 4R sin A by 2 into cos of P by 2 minus C by 2. So we get R plus R1 is equal to 4R sin A by 2 into cos of B by 2 minus C by 2. Further here we have to take R2 minus R3 and we have to find that is also. Now consider R2 minus R3. Now consider R2 minus R3. Say R2 minus R3 is equal to, so what is R2 here? 4R sin A by 2, 4R cos A by 2, 4R cos A by 2, 4R cos A by 2 and sin B by 2, sin B by 2. So cos C by 2, cos C by 2 and minus R3 we have 4R cos A by 2, cos A by 2, cos B by 2, cos B by 2, sin C by 2. Sin C by 2 we have. See in both 4R and cos A by 2 common. So take out 4R cos A by 2, 4R cos A by 2 and we get here, after taking the 4R cos A by 2 common, sin of B by 2, sin of B by 2 into cos of C by 2, cos of C by 2 and minus, after taking 4R cos A by 2 common, so we get cos of B by 2 into sin of C by 2, sin of C by 2. See, observe here within the bracket. So this is like sin A cos B minus cos A sin B. See, we have sin A cos B minus cos A sin B, the formula standard form, sin A cos B minus cos A sin B, which is equal to sin of A minus B. So what is here A and B? A is B by 2, B is C by 2. So now which becomes, so 4R cos A by 2 into here sin A minus B. A is B by 2 minus B is C by 2. B is C by 2. So therefore finally we get R2 minus R3 is equal to 4R cos A by 2, cos A by 2 into sin of B by 2 minus C by 2. We get R2 minus R3 is equal to 4R cos A by 2 into sin of B by 2 minus C by 2. See, we have R plus R1 is equal to 4R sin A by 2 into cos of B by 2 minus C by 2. R2 minus R3 is equal to 4R cos A by 2 into sin of B by 2 minus C by 2. But what we have to prove that, so therefore R plus R1 plus R2 minus R3, which is equal to, we have to prove 4R cos C. So now which is equal to, here R plus R1, observe here we get 4R sin A by 2, sin A by 2 into cos of B by 2 minus C by 2 and plus, so here R2 minus R3 we have 4R cos A by 2 into sin of B by 2 minus C by 2. In both the terms, which is common here, 4R is common. So taking 4R common, we get sine of a by 2 into cos of b by 2 minus c by 2, and plus, after taking the 4r common, here cos of a by 2 into sine of b by 2 minus c by 2. See, observe here within the bracket, which is in the form of sine a cos b minus cos a sine b we have. See here sine a cos b and here plus sine a cos b plus cos a sine b. So what is the formula for sine a cos b plus cos a sine b? We have sine of a plus b. Sine of a plus b. What is a here? A is a by 2. B is completely b by 2 minus c by 2. So now which is equal to 4r into sine of, so a is a by 2, plus, so b is complete b by 2 minus c by 2. So which is we get like sine of a plus b. Now which is equal to 4r into sine of, it can be written as, so a plus b minus c whole divided by 2. See, already we know that the property of the triangle is a plus b plus c is equal to 180 degrees. So from this a plus b is equal to, we can write 180 minus c here. So now here a plus b is replaced by 180 minus c. So this is sine 180 minus c by 2. See, further what we can write, which is equal to 4r sine 180 minus c by 2 is nothing but 180 by 2 minus c by 2. 180 by 2 minus c by 2. So which is equal to, so 4r sine, see 180 minus here 180 minus c and minus c, here a plus b is equal to 180 minus c. So it is nothing but 180 minus c, that is minus 2c. Here also minus 2c we get. So here, so 2 90s we can cancel. So that's why here 4r sine 90 minus c. Here 2 gets cancelled. 90 minus c, which is equal to, so 4r sine 90 minus theta, it is in the form of, so that's why 4r sine 90 minus theta is cos theta, so that's why 4r cos c. So therefore we can prove that r plus, so r1, so plus r2 minus r3 is equal to, so 4r cos c. So this is only we require to prove here. Here 4r sine a plus b is nothing but 180 minus c. So that's why here 180 minus c, that is 180 minus 2c by 2. Now here 4r sine 180 by 2, split the denominator, 180 by 2 minus 2c by 2. So this is 180 by 2 is nothing but 90 and 2c by 2 is nothing but c. So 4r sine 90 minus c is like 4r sine 90 minus theta. Sine 90 minus theta is cos theta, we know that. So that's why 4r cos c. So like this we can prove that r plus r1 plus r2 minus r3 is equal to 4r cos c.